Okay, an airline is analyzing the punctuality of its scheduled flights. Okay, it measures departures and arrivals and classifies them as early, on time, and late. Let's make a note of that. Departures and arrivals, early, on time, late. Those are the key aspects of this question, essentially. Okay, so from its records, no flights depart early. That's sort of an important little point. And 85% depart on time. Okay, so implicitly you could say that 15% must depart. Let's rub that out. 15% must depart late. Now, arrivals are early 10% of the time and late 20% of the time. Now, that is going to set up the first question. So, the first question is determine the probability of a flight arriving on time. So, what we're going to do here is set up all the events that we're going to use to describe our situation. DO means departs on time, DL means departs late, and I really should have put in DE here, whoops, to mean depart early. Now, no flights actually will depart early, but we have to sort of spell that out explicitly. Okay, now let AE mean arrives early, AO means arrives on time, and AL means arrives late. Okay, so given all the pieces of information that were told there previously, let's just sort of explicitly state them in mathematical language. And I have DE here again. So the probability of departing early is 0. As far as this study is concerned, it does not happen. Okay, so that's that one. The probability of a departure on time is 0.85. Okay, now it's going blue there for some reason. Arriving early is 10%, 0.10, and arriving late is 0.20. The probability of arriving early and arriving late is 0.10 and 0.20 respectively. Okay, so the question asks, what is the probability of arriving on time? Probability of A0. That is the complement of arriving early and arriving late. There's only 3 ways you can arrive: on time, early, or late. The entire combination of the entire addition of those probabilities is 1. So what we're using here is the complement rule, and just like I described there, it's actually a very simple question. So essentially 70% of flights must arrive on time. So we're going to move on to the next part here. Further analysis shows that none of the flights that depart late will arrive early, okay? And 10% of the flights that depart on time are late arrivals. So what we're going to do is state this in terms of conditional probabilities. The probability of arriving early, given that you have departed late or your flight has departed late, is 0, okay? No late departures will arrive early. And given that you have arrived late, the probability that given that you have departed on time, the probability of you arriving late is 10%, 0.10, okay? Now, it's very important that you have conditional probabilities straight in your mind, and I nearly made a small mistake there myself. So probability of AE given DL equals 0.00 and so on. Now remember, let's just sort of think through this again. None of the flights that depart early will arrive, or depart late will arrive early. So just be careful of the sequencing there and how that is phrased. Now, so the second part is part B, okay? What is the probability that a flight will arrive on early, given that if its departure is on time, okay? So what essentially we are asked to find is probability of AE given DO, okay? Given that it departs on time, what is the probability that it arrives early? Now, so we have to think through a couple of things here. So just earlier on we said that there are no early departures, okay? And so there's a consequence of that you can't arrive early if you've departed early, because you can't depart early. So the probability of AE given DE is 0, okay? Now, what we're also told explicitly is that the probability of AE given DL is also 0. So there's only 3 ways that you can depart. Early, well, actually you can't, but you can't arrive early. If you depart late, you won't arrive on time. So the only way you arrive early is if you depart on time. So what we need is this here. So what we're going to do is set up the conditional probability formula, but this is an important little milestone. That's something we're going to use in our conditional probability formula. The probability of A, E, and DO, the probability of arriving early and departing on time, is necessarily the same as the probability of arriving early, because you can only arrive early if you depart on time. So essentially, they're the same thing. That last point is very important, actually. It sort of demonstrates the fact that you should always think about the situation that the symbols and the letters are trying to describe, and just try to think through it properly. So, what we're going to do now is use the conditional probability formula. Okay, this is using the notation of this question to answer in the formula. The probability of AE given DO is equal to the probability of AE and DO all over the probability of DO. That's just a re-expression of the conventional conditional probability formula. Okay. Now, the probability of AE and DO is just actually the same as the probability of AE. We're told that earlier on that the probability of an early arrival is 0.10. Okay, and we're also told that the probability of a departure on time is 0.85. So this actually works out to be a very straightforward calculation. 0.1 divided by 0.85, that gives us 0.1176. Okay, and that is the answer to part B. What is the probability of arriving early given that it departs on time is 11%, nearly 12%. Okay, so let's set up for the next part of the question. Show that the probability that a flight that both departs on time and arrives on time is 0.665, 66.5%. Okay. Hold on, I just realized those should be plus signs. I'll just change that. That should be plus. Okay. So, probability of departing on time can be broken up into three parts. It could be the event, the combination of the three events, arriving on time and departing on time, arriving late and departing on time, and arriving early and departing on time. Okay, so it's a sort of combination of those three events. Okay, now what we need to find out is what is the arriving on time and arriving or departing on time. That's what we're asked to find out. Okay, so we have enough information from elsewhere. Okay, in the just previously we were told that the probability of arriving late, given that it departed on time, was 10%, 0.1, and we know that the probability of departing on time is 0.85. So that means that the probability of arriving late and departing on time is 0.085. So that's just using one key piece of information that we needed from earlier on. Okay, so what we have here is, what we need to find out is this part. Essentially, we know that this is 0.85, and now that we know what this is, that's 0.085. Okay, so likewise, what is the probability of arriving early given that it departs on time? So we actually found that out previously, something we described already. Probability of AE and DO is essentially 0.1. Okay, so that is 0.10 there. So essentially, this part here is where you have to build your answer from, and just use all the key pieces of information that you were told earlier on. So that last part there is coming from question 1. We know that the overall probability of departing on time is 0.85. So essentially, this is the part we have to find out. I sort of went around explaining my rationale there in a very circular fashion, but I think we have all the main points there. So what we could do now is just re-express that expression I have up there up top. And essentially what we're doing there is just rearranging it arithmetically such that we have probability of AO and DO arriving on time and departing on time is the difference of all departures and that departures, on-time departures, when we exclude the early arrivals and the late arrivals. And just as we sort of found out there, the late arrivals that depart on time, 0.085 and 0.1. When we just subtract those from 0.85, what we get is 0.665. There we have it there. So that's the answer to part B, essentially. So it's just using this, and just to recap on my rationale there, it is essentially using all of the key pieces of information that we have and putting it into that structure there. That's essentially a total probability approach to answering this question. So this is part D. What we are asked to do is determine the probability that a flight will arrive on time if it departs late. And recall that there are no early departures. So let's actually just look at the formula. I have it just written down here that we're going to use. Okay. So here it is here. The probability of AO given DL, and that is equal to, using the general conditional probability formula, probability of AO and DL over the probability of DL. So what we're going to do here is find out what the probability of AO and DL. Now this is using the same approach that we used in part C to find out how to tackle this question. So it's using the same approach. Recall that there are no early departures. So what we know is that the number of on-time arrivals, the probability of an on-time arrival is 70%. And we know that the probability of an on-time arrival that departs on time is 0.665. So the number of on-time arrivals that depart late are also depart late is 0.035. Okay, so essentially what we're going to do there is put that into our formula. Now earlier on I sort of mentioned that the probability of a late departure is 0.15. There are no early departures. There are 85% are on-time departures, so necessarily 15% are late departures. Okay, using our conditional probability formula, 0.035 divided by 0.15, I'm down here again, okay, and that works out to be 0.233. Okay, so 23.3% of flights is the answer. That is the of late departures will arrive on time. So that's that part. I'm just going to set up for the next part. So the last part is part E. Determine the probability that if a flight arrives late, it departs on time. So if a flight arrives late, then it departs on time. Okay, so what we're asked here is the probability of DO given AL. Now really the trick there is just actually, it's a conditional probability question, but just actually what given what. What is the probability that if a flight arrives late, that it departs on time? So it's given that it arrives late. So as opposed to arriving late given that it departs on time. So this is what we're asked here, the probability of DO given AL. And what we are going to do here is use the conditional probability formula here again. Now we've actually worked out all of these numbers. We worked out 0.085 previously in part C, and we were told 0.2 for arriving late very early in the actual question. So using the conditional probability formula there, it works out to be 0.085 divided by 0.2, and that gives us 0.425. So a nice easy one there to finish with, but always remember to read the question properly. A given B or B given A, which is it with conditional probability? Okay, we'll leave it there.